Hey robot makers, hope you're having a good day so far. So do you want to make a text scroller using a Raspberry Pi Pico and a Pimoroni Pico Unicorn Pack? Then this is the show for you. So let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. I certainly had a load of fun this weekend as I was putting this text scroller thing together. Got a bit carried away. We'll talk about some of that in a second. So yeah, the session goals for today are to make a text scroller using a Pico Unicorn Pack, which is that little display there. We'll have a look at all about this. And we'll be looking at the stand as well, which I've created specifically for this. I've made a whole series of these little stands. We'll have a look at those in a minute. I had a load of fun creating fonts for the display. So I didn't use any fonts off the internet, any found stuff. I created my own, and I encourage you to do the same because it's so much fun. And then I created some code in MicroPython to scroll that text across, and we'll look at how I've done that. And I think it's quite a crude way, but it really works very fast. And we'll also look at the proper way of doing it and why that's also quite slow and complicated, but it's the right way to do it. And then we'll have some demo and play with code as well. Okay, so the Unicorn Pack, if you've not heard of this, this is a product from Pimoroni. I purchased this myself, so it's not a sponsored particular one. It's a great little pack that goes onto the back of a Raspberry Pi Pico, like this one. So the way that they name their products, if it's a hat, it goes on top. If it's a pack, it goes on the back. So this goes on the back of a Raspberry Pi Pico. And it has 16 by 7 rows of RGB LED pixels, so they are individually addressable. We can make them any color we wish. So there's 112 pixels in total that we can address, and they're in this nice grid array, so it's 7 rows by 16 columns across. There are 4 tactile buttons as well, so we can program them if we wanted to. I've not used them on my particular use case here, and everything's sort of pre-soldered, so you just push it onto the back of the Pico and everything works perfectly. And it's obviously compatible with the Raspberry Pi Pico or any other boards that use the exact same pinouts, but it's designed for the Pico. And yeah, dimensions, it's just a little bit bigger than a Raspberry Pi Pico. It just covers the back, and then it's a little bit wider, a little bit taller as well. So 25 millimeters by 62 long, and then 10 millimeters high with the buttons and the headers on the back. Okay, so the Unicorn Pack use cases, on the back of the packet, they talk about you could have this as a name badge. I guess they developed this before they released the Badger 2040, because that's I think that's a better use case for the as a name badge. But you can use this. There's nothing stopping you from using this as a sort of interactive, scrolly, flashy, lighty name badge. Probably catch more eyes with the colours and the scrolling text that we'll look at. They've got there as well mini RGB LED lighting. It is quite small lighting. It's not massively bright. It's bright enough, but it's not like going to illuminate a room or anything. So I think that's a little bit tongue-in-cheek, that one. And then zoom chat status light. So yeah, you could program this so you hit a button and it goes like red to say that, you know, you're live, and you could have another one which is like, you know, vacant or available to chat. So you could have that on your desk or work or wherever. And of course you can use this to scroll text as well. Now I was very surprised out of the box it doesn't have a text scrolling functionality. That's something I had to create myself, but this is what I was going for. I wanted to create my own YouTube subscriber count. You sometimes see this in the, you know, behind people when they're sort of streaming, and they might have like their current subscriber count on that. And I wanted something like that on my desk so I could just keep an eye on that. And we'll look at some of that later on. So creating your own fonts, this is so much fun, I can't express to you. So all you need to do is just get a piece of paper. I use this sort of dotted notepad paper, and just create a little grid on there, and then start drawing up some characters. So you'll need to create a glyph, which is the name of the symbol for each character in the font that you're going to create. And also think about things like uppercase, lowercase. Think about being consistent with the X height, and the X height is this sort of bar that goes across. You can just get that there. That goes across there. So we want to be consistent with things like that. And we haven't got a lot of space on this particular font I've designed. I've made this one so it's 5 pixels high. I could have gone for 7 pixels or 6 pixels. I could have gone possibly to 4, but you're really pushing what's possible with a display. If you're trying to cram characters into something like 4x4, I'm sure you probably could do that, but it'd be quite illegible, I would guess. And yeah, you need to then create a Python file that you're going to create these in as a list, and we're going to have a look exactly how we do that in a moment. So we need to define these glyphs in code. The easiest way I found was to define it as a list. So you can see there we can just define zeros and ones, and we can create them in a list, and we can separate them by a comma and then neatly put them underneath each other. Really, this is just for our own benefit. Python doesn't care that they're arranged like that. It just sees them as groups of five rows, if you like. And I've also made this so that we can make it proportional, so we don't have to have the same number of columns going down on each character. We can have more or less. As long as each row has the same number, that's fine. So some of my characters have got 1 pixel wide, if it's like the letter I or possibly the letter L, and also like a full stop or a colon, they can be a single pixel wide. And other characters like letter M or W, they're probably going to be the full 5 pixels wide. Everything else is a kind of a mixture of that. So what we do is we simply just say like a variable like a equals, and then in the square brackets, which defines our list. And then now what I've done on this particular one, and you'll just have to bear with me, I've created a text string, and then I've done like 0110 for the top part of the letter A, and then a comma just means it's like a new element in that array. So we've got 5 lots of things in the array. And then you have that square bracket to close that list. And then whenever you reference that letter A, the variable, you've got the contents of that as 5 lots of strings, if you like. It's not very efficient, and we're going to have a look at how we can make it more efficient and why we would want to do that and so on in a minute. So essentially, each one becomes a black pixel, and each 0 becomes like a white pixel, because we're just black and white fonts. We don't have coloured fonts. We apply colour to the font. So that's how we store it. Each element in our list is one of the different rows, and each has 5 rows. We have 5 lists. Sorry, let me say that again. Each list has 5 rows, 1 list per character. It's not very memory efficient because we're actually storing 5 or possibly 10 bytes for each row. So it's 50 bytes per character. That's quite a lot of memory, given our Raspberry Pi Pico only has like 264 kilobytes of memory. So we want to make sure we don't max out on that by having like too many fonts with too many character sets. But it's quick and dirty, it works fine. I've not come across any problems with this so far. So the way that we could do this much more efficiently, and I had to play around with this, and I probably spent most of Saturday afternoon and some of Sunday morning trying to get this worked for the show, but it ended up making the code really, really complicated. So what we can do, instead of defining it as a string, we can still do that 0, 1, 0, just write it in binary, but actually store it as a binary number. So if we do 0b, that tells Python that what follows is going to be a binary number. And that means that we can store this in a lot less memory. So what the little calculation I've got down there says the old method, which is just storing it in a string. So if we had 5 characters in a string, that would be 5 times 2 bytes, because I think it's Unicode and it stores each character in 2 bytes. So that would mean with 5 lines, that's 50 bytes per character. Whereas this one, it can store each row as a single byte with a bit spare left over, to be honest. And that means we've just got 5 bytes maximum for each character, and that's a lot smaller. So we can be a lot more efficient with our memory usage, but it does mean that when we read that in, we then have to unpack it. And the unpacking bit is where the complication comes in, because you can unpack this using the bin function in Python, and that means that you can then get a text representation of that binary number, so it kind of converts it back into this, but it doesn't have the leading zeros. So then we have to have another function that then adds leading zeros, and all these things add complexity and also slow down our scrolling function. So we can then look at different ways of building out our scrolling function using things like frames in the frame buffer, and this is where it gets more complicated. So I think we can actually ignore all that for now. We can be aware that that's probably the proper way to do this, but we can just ignore all that and follow the code I've written, because it's very simple and easy to read. So this is the font I created. I had loads of fun creating this and tweaking it and making it just sort of my own. So I've called this one Johnny 5 after the poster, which is behind me just there. That's the you can just see it short circuit. Johnny 5 is just there. So this is why I've called it that, and it's just a very simple typeface. It doesn't have every single character. We could certainly build out more if we wanted to, more glyphs. So it's proportional. So you can see there that some characters, if I just get my mouse here, like the number 2 has 5 pixels. The character A has 4 pixels wide, and 4 pixels for the N. The T is 5, the U is 5, the V, W, X, Y, and Z are all 5. But some of the ones, like the lowercase I, that's 1 pixel wide. Now on here, I've actually just done a 5x5 grid. But when we store that, we can actually just store it as a single column of pixels. So we'll have a look at that in the code in a second. And that means that we can make it proportional so that when we're scrolling on our very small display, we want to make sure that we're not just wasting wasting space on our display, because if there's like 5 characters and then 5 pixels, a space, and then another 5 pixels, that's nearly the entire display for just 2 letters. So by making it proportional, we actually squeeze a lot more on the display. So that's one of the reasons I did this. It's actually very easy to do as well. We've got capital letters, we have lowercase letters, we've got numbers in there, and then we've got some common symbols. So I was thinking about, what would I use this for? Probably stuff to do with, like I said, YouTube subscriber counts, maybe email addresses, maybe web links. So I wanted to make sure I had everything in there that I would probably commonly use to this, to scroll across on here. So I've got like the @ symbol, got some brackets, a dollar percentage sign, that's an ampersand. We have the pound or hash symbol if you're in the UK. We've got speech marks, double and single. We have a star, a plus, a minus, a comma, full stop, forward slash, backslash, somewhere in there. I think I've maybe not drawn that one on, but yeah, I've got the forward slash and backslash. Oh, there it is. There's the backslash. Square brackets, the caret, underscore, some more arrows, an exclamation mark, a tilde, the UK British pounds symbol, the euro. I think that's... I have no idea what that is actually. I copied a few of these from something I was looking at online. And the pipe symbol, that's quite a common one. They're probably the most common ones. We're going to use the equal sign as well. So really fun doing this. What I enjoyed doing was creating them and then going back and making sure that like the X height was all the same, so that they have like a common look and it looks quite natural to read. I did change out the S. I thought when you saw that on the display, it didn't quite look right, so I've actually made the S a little bit taller, so the X height on that one is actually on the full 5 pixels tall. So the Pico stand. So when I was playing with this Pico Unicorn pack, not display pack, I wanted something to present it on. So I created these little stands, and the idea is you get your, let's get my little Raspberry Pi Pico, and you can just essentially screw into the back of this, just using a couple of I think M2 screws. They have to be quite long, but M2 screws, and that will just sort of hold that in place, and then you can push the pack on top of it there. And these sit really nicely on the table. If I go to the overhead camera there, I've got one there, and you can just see they sit quite nicely. And I've also got a few other ones. If I just pan out a little bit there, you can see we've got the Enviro hat there. That's on the Zero stand. I've got the Sense hat, and that's on the full Raspberry Pi 4 or Raspberry Pi 3B or 2B stand. And then we've got the little Pico stand down here as well. Now I am cheating a little bit on this one. You can probably just about see there's a tiny bit of blue tack on that one. The very first iteration I did on this one, I think it was a bit too long, so I've gone back and edited it and corrected the file. So we can have a look at that in Fusion in a minute. But there's plenty of space there for things like the cable to go in, and it sits very nicely on the table. So let's just zoom back in on that so we can see it a bit better, like so. And if we just turn off the lights for a second, you can also see how bright that is. So it's a really nice display, and it's sort of cycling through some colours as well. We'll have a bit more of a demo on it in a second, so I just wanted to show you that. Okay, so really sturdy design. It's a single piece, very quick to sort of throw together as a design. Doesn't take too long to print these out. I can't remember the exact print time now, but I tend to print them like with the face pointing down. Oh, actually, did I do that on this one? I think on this one I didn't do. I think I actually printed it like that. It doesn't require as much support as if you're doing it face down, actually. So forget that. Print it just the way that it appears as the STL file. So very easy to hold a Pico. Space for a USB connection. It's very sturdy. It's quite forgiving as the thing. I've dropped these a few times. It's a single piece design, so it's very easy to print out. And if you want to get a copy of that for free, just head over to, and there isn't an S in this, so it's HTTP, no S. And then www.kevsrobots.com/blog/pystands.html. So really helpful and useful to have these. I've got loads of these. So I have the Pi Zero stands. I have one for our Grow hat. So we've got that in our kitchen, just displaying this sort of water levels for the plants that we're growing, some of the chilies we're growing. I have one at the back of the room which is displaying the weather station stuff, so that's sat nicely there. And then on the desk there I've got the Enviro hat, which is just doing some environmental monitoring of where we are. And now joined with that is the Pico stand as well. So if you want to grab one of those, help yourself. And I'll show you the website in a moment too, you can have a look at that too. So scrolling text. So I was thinking about how do we go about this. I was quite surprised that the Pimoroni library didn't have the stand built. It didn't have the scroller built in. The Sense hat, which is from Raspberry Pi, they make it really easy. Just sort of say show message, put a message in the brackets, and whatever you type in there, it will just sort of scroll past. But their scroll display only has 8x8 matrix of LEDs, and I think they're just white and off. So they haven't got that sort of colour which we have in the Unicorn hat pack. So I was thinking about how would I go about creating a text scroller. I know it would involve just a couple of loops and having some kind of frame buffer or something like that. So that's what I sort of started with thinking. I'll create a new class in Python and we'll go through the code, don't worry. But I just wanted to sort of give you a kind of an overview and then we'll dip into the code properly. So what I found also really nice and useful in Thonny is you can click on the view and then outline, and it will give you an outline of all the code functions that are in your code that's loaded up. So you can see there the scroller class has only 5 functions, so it's quite simple. The first one is the HSV to RGB. And what this does is it takes a hue, saturation and brightness, sometimes called V for value, and it will take that and it will convert it into the red, green and blue, the RGB values. And the reason we want to have that is it's really easy to work in hue, saturation and value, because we can do things like bring the brightness up and down, make our display pulse. The colour is a little bit weird, but we can also use the hue, which is like kind of a colour wheel. Starting at the top is 0, and then working you all the way around, like halfway down would be 0.5, and then all the way back to the top would be 1. And 0 and 1 are both red. And I think at sort of degrees out from that, so at like 60 degrees, I think is either red or green. I'm going to go with green, and then, sorry, green or blue. And then on the other side, I think it's blue at 120 degrees on the circle. And then back up to the top, 360 and 0 are both red. I think that's the right way round. And every imaginable colour throughout that as well. And then the saturation is just how much white there is versus how much of the colour is coming through. So if we had a value of 0 for saturation, there would be no colour. It would just be like white or like light on or off. Whereas if we put the saturation all the way up, we get the full strength of the colour in there. So we can make more colours just by changing the saturation. So we've got the opposite function as well. We've got RGB to HSV, so that just does the opposite, just converts an RGB value into a hue, saturation and value if we want to do that. I don't think I use that in this code. And then we have a clear, which just clears the display. We have a display character, and that's used by the show message function. And the show message function essentially just goes through each letter in the message string and then displays each character. It finds it in our font array and then works out which pixel to display, and then displays it on the Pico display. So that's the display character, displays a character, show message, it takes the whole message and then breaks it down from there. So how show message works, it's ugly code, but it works, and it works very, very fast. I was really surprised when I started doing all the complicated stuff with the binary and unpacking and all that. The scroller display sort of really slowed down, and when I went back to this code, which I wrote first, it's really, really fast. So although it looks ugly having an if statement of every single character in your font, it's very quick from an execution point of view, because it can just say, if it isn't that, next, 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 and it can make those comparisons very quickly. So let's have a quick look through. We first of all set the hue value. We take that in as a parameter, so hue is a parameter, and that's essentially the colour. If the colour is none, we just say it's 1, which is red. Otherwise, we just set the internal value. Self.hue means within our class, we're going to keep hold of this value for this particular object. Then for characters in message, so we're going to pass in a message such as like, hey robot makers, for each character in there. So it's going to go H and then E and then Y and then space. It's going to work out each of these characters, and it's so for each, that's a loop there for each character in message. If the character is A, then display character A at the position, and position we've not looked at yet. We brought that in as a variable as well, and that's the position on our Pico's unicorn display. Now, we've only got 16 spaces to display bits of characters on there, so we need to have some way of sort of scrolling this across, so there'll be stuff outside to the left and other stuff outside to the right, and we can do a quick comparison inside our display character to see is it within the bounds of our view window, and if not, we just ignore it. So it does mean that the speed can sort of speed up and slow down a little bit. I've noticed that, and it can also get a little bit flickery if you've got really long strings that you want to display, messages you want to display. So what we do then is we say, so for each character in the message, check if the character is a glyph. So if it isn't, if we pass it something, it'll just ignore it and not display anything. And then we display the glyph at the correct position using the display character. Okay, so let's go to the next one. And we've now got the display character. So this is going to loop through each pixel in our font for that particular glyph, and then it's going to transfer that by just setting the pixel. So for each row, and we can see at the bottom there we have, so that's just popped up there. We can see there we have, for each row, we have 5 rows because it's 5 rows tall, and then the columns are the ones that are going down. So for each row, we are going to say, in the range of 0 to 5, so I've made it so that a max width of 5. I've hard-coded that. We could probably make that a little bit better by just checking what the maximum width is. I think I did that on later code. Again, these things slow it down, so maybe we have to pre-calculate them. We then say the length is the length of the character. So what I mean by that is, what is the number of pixels wide in our string? Because some of these, so on this letter A here, I wouldn't actually store those spare ones at the end. Those blank ones, I would just store 4. And we'll have a look at that in the code in a second. So that means that each character has a different length. So we just grab the length by just looking to see the first element in there, what's the length of that, and that sets the length for this whole row of things we're going to go through. And then for each column, so then we're going to look at each individual pixel. So if that's in the range of 0 to length, and it shouldn't be outside of that because everything should be inside of that, we'll then say the X value, because we're going to transfer this X and Y on our display. So if X plus 1, because X starts at 0, just to confuse things, and our array will count from 1, so we just need to adjust that. So if X is 1 and it's less than 16, because we've got 16 things on our display, and X plus 1 is greater than minus 1, so it's within the bounds, that's what we're saying there. Then we set the pixel using the Pimoroni Unicorn library. So X plus 1, Y, and then these 3 values here are just color values. So initially, we're going to clear the gap. So when we write a letter to the screen, we want then a 1 pixel gap between the next character. So that's what this does. It just sets everything that's in there. If we don't include this, we get whatever was last on there as it scrolled past, and it looks messy, so we need to set that. And then to actually write the pixel, so if X is less than 16 and it's greater than minus 1, then let's set the character. So if the character row and column equals 1, as in it's a 1 in our glyph down here, so that's a 0, that's a 1, that's a 1, that's a 0, that's a 0. So if it's a 1, then we set the pixel, and we bring in the red, green and blue values that we've converted up the top here from our hue that we brought in. Otherwise, we just set that to 0, 0, 0, which is black, which is everything's off. And then the last part we say self.offset plus equals the length of the character plus the gap. So what that means is, whatever our current position was, add the length of the character that we just brought in. So if it's 4 pixels wide, add 4, then add another gap, which we've set the gap as a value 1. So self.gap is something we can define in our font if we wanted to space them out really wide because we had a much bigger display, for example. Or if we wanted to animate that, we could make them go wider and smaller and they'd look like they're bouncing. We could do all that kind of crazy stuff too. So if you like these videos, make sure you check out every single Sunday, 7 o'clock British summertime currently, but usually Greenwich Mean Time in winter period. So UK local time, 7 o'clock, which is usually currently GMT plus 1. It's normally GMT. And we go live every single Sunday, so you want to catch that, you can join in the chat. And if you really want to help me out and do me a favor, then make sure you like this video, give me a comment, tell me if you have done any text scrolling type things. Have you used are you going to download these little things? the stands, and make sure you subscribe to the channel as well. That really helps. We were looking to see, of all the people who've ever viewed this channel, if they all subscribed, I would have over 500,000 subscribers by now. So most people don't subscribe, and they just watch the content. So don't be one of those people. Don't be like everyone else. Subscribe. And if you want to join me on Discord, we have a really vibrant Discord group where we sort of hang out, and you can head over to https://action.smilesfan.com/join-discord, and you can join the Discord group there as well for much deeper conversations. So one of the next steps before we get into the demo of this is what I actually intended this for. So I wanted a YouTube subscriber count display. So on a different computer, I've got another Raspberry Pi. I'm going to use the one that actually has the Sense hat on it, for example. I can plug this this Pico display into that, and I can grab the YouTube subscriber count using the YouTube API. So I've got some code that can do that. You have to create a token on their site, and then you have that token as a secret and so on. But essentially just poke their API. It gives you back a whole block of data, and then within that there's like a subscriber count. So you can just pull that out and then do something with it. So I thought, well, rather than just hide it in this piece of code, I'm going to broadcast that on my MQTT server, so that if anybody else wants to listen to that in my local network, they can subscribe to that MQTT server and then do something with it. So one of the things I did a while back on this channel was create a Raspberry Pi Pico with Wi-Fi. I think it's one of the quite popular videos, and I used a Wemos D1 Mini to provide that Wi-Fi link. So the Pico and the Wemos D1 Mini simply just have an RX and a TX, a UART between each other, and the Wemos can subscribe to a topic on the MQTT, and then any data that it gets, it can just send it to the Pico, and the Pico could do stuff with it. So in that case, I could broadcast the subscriber count, and then it could just push that to the Pico, and then that could scroll it across. The only thing I found out the hard way with the YouTube API is that they limit how many times you can poke that API and get a value back. I think it's 10,000 times a day. So I had something running every couple of seconds, just grabbing the YouTube subscriber count. I'm that optimistic, just for any changes that would appear, so I could get a real-time thing, and obviously I can't do that every second, so I need to sort of dial that back. So maybe it's every 5 minutes, every half an hour, it grabs the latest count and then just displays it, broadcasts it. So that's something that I'm going to be looking at changing the code. I didn't include it on here because it's not really specific to scrolling text or the Pico Unicorn display. I just wanted to sort of cover that we can do this, and we can look at the code if anybody's interested in that too. So yeah, we can display the count of YouTube subscribers using our code. We can have our little stand to display it on, and then living the dream. Okay, so let's get over to the demo. So I'm just going to get everything in place here. So I've got Thonny, and I'm just going to load up the demo code. So if you want to have a bit of fun with me on this, if you're in the live chat right now and your name displayed on the display, and it has to be a shortish name, I can't put like a massive little long one there because I want to try and put quite a few people on, just message in the chat and Alex will then just send them over to me in a minute, and I'll cut and paste them into our code, and we'll play with that from there. Cool. So let me just go over to Thonny. Here we are. And yeah, what I was saying about the scroller, if I click on the scroller code here, and I go to the outline, do I have to go to the top there? Let me just stop that code from running. And we can look at things like the variables and the outline there. We can see we've got the scroller, and there's all the different functions that we have. So if I created like a new function in here, let's just call this one hello. Now let's just put the word self in there, and then it's not going to do anything, it's just going to pass. If I then look at the outline, you can see there I've got hello. So that's what happens when you add functions to the class. So really helpful for just navigating your code and understanding where things are. So I think you can actually use that to navigate to. So if I click on display character, it jumps straight to it. So let me go back over to the demo, and let's just have a quick play around with the demo and see what we can make this thing actually do. So if I go to that display there, and I bring my code down like so, actually probably the best thing to do is bring it up like so. Trying to arrange everything on the screen so we can see everything at once. So yeah, that doesn't need to be there, and then We can probably just scroll just to about there. Perfect. Okay, and then I'll just make the font a little bit bigger, just so we can see what's going on. There we go. Like so. Okay, so the Pico is plugged in. It's not doing anything at the moment. We can just see the display just here, and we have the code. So the first thing I do is I import my scroller class. We'll have a look at that in a minute. I also import sleep from the time library, and then I've got a couple of different messages we can swap in and out here. So let me change this to be just Kev to begin with. So I'm just going to comment that one out. And then if we scroll down here, we initialize the scroller library, the object, by just creating scroll from the scroller class. I set the hue to red, which is 0, and we can have a play with that in a minute to see what that does. And then I clear the display just using the scroll to clear function, which we can see just on the right hand side. We've only got these 5 functions to play with. And then I've got a little loop. So the loop says, while true, or the keyboard interrupt, which is something I've learned recently, and then for position in the range of 16, which is the number of pixels we have across our display, minus the length of the message, and then we just times it by the number of, what is that, 5 plus 1, can't remember why I put that in there. I think I've just added like a bit of extra space at the end. I think, yes, it's the gaps between the letters. And then -1 is just how many steps. So we're going to count down from 16 to the length of the message, and that should be enough to make it scroll past. Then we say if the hue is less than 1 or hue equals 0, then we increment the hue, so we can make it change the value, and we can play around with that in a minute. So actually, let's make our code really simple to begin with. Let's comment that out. We've set our hue to 1. We're not going to do anything else, and let's just remove that as well. And then we just say scroll.show message. The message, which we've defined at the top there, is just being Kev in lowercase. The position we've just passed in, and the position is part of the loop. That's the thing that's going to make it actually scroll. And the hue is the color which we've set is red. And we're going to sleep for, what's that, 100th of a second, 1000th of a second, something like that. Right, let's run this code and see what happens. So there we go. Kev is scrolling past, and it's scrolling quite fast. So what we can do is we can just dial that down a bit by changing that sleep function. So if I do that, there you go. It's a bit slower now, so you can see the word Kev is scrolling past there quite nicely. Again, if I turn off the overhead light, might be able to see that a bit better there. So Kev, and if I just leave that there like that. So I can now change the case of that. So if I scroll to my code there and I uncomment the uppercase one, let's try that out, just rerun the code. And we'll now see that it says Kev in all caps. Now remember what I was saying about the width of the characters. The word Kev, just 3 characters, takes up the entirety of the display with the spaces. So actually having proportional size fonts can really help with that, because these letters, if I go back to the lowercase ones, they only have 4 characters wide, or even less sometimes. You can see there, you can easily fit the word Kev on there, and you can probably fit an extra letter in there as well. Maybe could have Kevin like that. Let's try that. We'll get most of that on there, maybe Kev it, and there you go. So very simple. Let's change and let's do Hey Robot Maker. So this is a bit of a longer string, so I'm going to run this, and so it says Hey with a capital H, EYs are lowercase, and then robot, capital R, and then makers, capital M. You can see some more characters there. And the S, you can see, has got that a little bit higher because it just looked a bit squished when I tried it with just 4 pixels high. But it has got the exclamation mark as well in there too. So we could also include on here, let's try my Twitter handle. So if I go Kev's Mac, so using the @ symbol, let's try that. See if I can get that to work. There you go. There's the @Kev's Mac. Scrolling across. Now that's all well and good just being in the red. Let's put that code back on by uncommenting that out, and let's run this and see what happens. So it's going to increment the hue by 0.1 each time it scrolls a letter past. And you'll see there it's starting out, it looks bluish colour. That's quite purple on the screen at the moment. It's now red, going to green. That's green, going to cyan, blue, and then purple going to red, yellow, and back to green again. Not sure you can catch all those different colour changes there. Maybe if I scroll up speed up the scroll, adding that extra 0 in, just because there's more flying past, we'll see it change a bit quicker. There you go. Okay, so that's a short piece of message. Let's try all the different characters. So I'm going to try this. I'm going to run this code now. So this is the entire alphabet. See if there's anything missing there. P, Q, R, S, T, U, V, W, X, Y, Z. Or Z if you're American, then numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I found it quite difficult to do them in anything less than 5 pixels wide. And then let's try the non-alphanumeric. They're quite quick to scroll past there. We've not got a space in between them. Maybe if we put a space in between each one of them, that would make it easier to read. So let's just do that. Rerun the code. You can see there question marks. We've got the arrows, we've got the brackets, the tilde, and the pipes and so on. So that's pretty neat, isn't it? I love pixel displays, me. I love it. Right, so that's those. Yeah, so what I'm actually going to end up with is the subscriber count. So what is our current subscriber count? What's the current subscriber count? Do we know, Alex? Let's have a quick look on, I think I might be able to grab it. So 6,703. So 6,703. Let's get rid of that, save that, and then rerun it. So this is what will happen when I have this plumbed in. I'll probably have it running a little bit slower than that because that's way too quick. So let's just slow it down by an order of magnitude. And there you go. So subs, and then 6703. Awesome. And I think I've got it switched on. If anybody subscribes during the stream, it'll actually come on the screen and I'll see that. Neat. So that's that. What else was I going to do? So we change the hue. Let's have a look at the brightness. So there's another block of code here. And I've said there, uncomment this section to make the brightness pulse. So we can universally change the brightness of all these pixels on the display. Again, I'm going to change the speed of that so that we can see this, the text scroll past quicker. And I'm just going to uncomment these 3 lines here. So if the scroll brightness equals 1, or the scroll brightness is greater than equal to 0.1, because the brightness value is like the saturation or the hue value, it's a value between 0 and 1. We then just say minus equals 0.1. So we're going to go from 1 down to 0 and then back up to 1 again. It's just going to make it pulse like bright and dark. So if I now run this, let's see what happens. You'll see it's sort of pulsing quite quickly. So let's slow that down and see what happens. So I'm just slowing down the speed that it's going past. You can see there it's sort of going dim and then bright and then dim and then bright. So that's just using the brightness function, and we're passing those things through to our class, and we're universally using that in our code. So pretty neat, isn't it? And we could use the full 7 pixels high if we wanted to. I just like them looking at 5 pixels as the particular font I'm using there. If I had more time, I'll probably create more fonts as well. So that is the demo code. We're going to have a look at the fonts themselves now. So the fonts themselves, so this version I went back to my original version, which is this one you can see now. The later ones, instead of just using individual variables to store the sort of array of characters, the array of pixels, I created I created a class for fonts. I created like a font name, the number of pixels wide, all that kind of stuff as like metadata in the font. And then I had dictionaries of letters and the arrays that make up those letters, rather than having individual ones. It's more efficient and memory usage to do things like that, and as well as instead of storing them as strings, I store them as these binary arrays. But again, I had to then start creating some code to unpack them, and it just made the scroll thing a lot slower, like 1 thing a second or less. So this is quick and dirty, but it really works fast. So the space character, I've just made that 2 pixels wide. The letter A, you can see there the ones represent the A, We've got the B in capitals, so you can see there the B in the ones, and the C, and so on. So some of these are 4 pixels wide, some of them are 5 pixels wide, and our proportional font scroller can figure this out. So pretty neat. So there we go. We've got all the capital letters. So let's just scroll down a bit, and then we have the lowercase letters. So let's scroll past those. I actually missed out the letter V when I was checking the code beforehand. So always test your code. And then because I'm using variables to store these arrays, I had to give them a name that made sense rather than just being the number 0, because it wouldn't understand that. So I had to type out 0 and 1, 2, and so on. But using the later method where I put them all in like a dictionary, I didn't need to do that. I could just store in speech marks the actual thing I wanted to represent, like the number 2. So you can see there we've got all the numbers. We then have things like the exclamation, the full stop, the @ symbol, the pound symbol. It's quite challenging doing this in just 5 by 5, but that's what makes it fun. The percentage, the ampersand, brackets, question marks, the caret, underscores, left and right arrows, forward and backwards slash, plus and minus, colon and semicolon, equals, tilde, single quote, and pipe. So they're all the characters I've got. I even thought about making a little font program in Python using something like EasyGUI or WX Python, which is like a library for doing graphics on your screen, user interface stuff, or even just Qt, just using the Python Qt library. So I looked at all the different TK Inter, that kind of library for doing stuff like that. But again, a bit of a rabbit hole you can go down there. This works just fine. So let's have a look at the scroller code. So the first thing we do is we import those fonts. We import everything from them fonts. We import the Pico Unicorn, which is the library for switching pixels on and off on a Unicorn pack. I am using the batteries included Pimoroni MicroPython firmware, just because it makes it easier. And I'm also importing sleep and math as well. And then we need to initialize the Pico Unicorn pack. And then I define my scroller. So I do things like the offset, the gap, the hue, saturation, and brightness. I just set them to all 1. The gap is the gap between the characters, and the offset is just where you are on the display. So a value between 0 and 16. We've got 2 functions for the RGB pixel stuff, so HSV to RGB. You don't have to worry about that. You can grab this code as well. The link is in the video description. RGB to HSV, and then we have the bits of code like clearing this display. So to clear the display, I simply just do 2 loops, and we just set the pixel to be black, 0, 0, 0. Now there's probably a Pico Unicorn.clear function I could use as well, but I just decided to use my own to just go through that. This is one of the areas where MicroPython is a little bit sluggish. Loops within loops is a way to sort of really kill your performance, but there's no avoiding that, I think, on this one, unless you wanted to manually put in how many times you wanted to run things, but you can do that. So Damien George did a really good YouTube video about how to make your MicroPython really fast, and it's basically just removing things like loops and doing it the hard way. It makes your code ugly, but it makes it very fast to execute. So then display character, that's actually used by, let's scroll a bit further down, the show message. So show message will take that message, such as like, hey robot makers. It will take a position value, which is where on the display we want to display it, because remember, we're doing that outside of this code. And then the hue value that we want the characters to display. And we're taking that as a single value and applying it to all the pixels that we're switching on and off so that we can do fancy effects with them. And then we say if there isn't a hue value passed in, because we made that optional, we just set it to 1, which is red. Otherwise, we set the internal value of the hue to be hue, which we passed in. And then we've got this massive long list of if statements, and look where it starts, 109. So for character in message, so for each character in the message that we pass in, we then say if that particular character is the letter A, then display the character A at the current position. And so 109 is where the code starts there, and we just keep on going through all the different combinations of characters, uppercase, lowercase, and we end up at 285. And at the very end of the code there, we just set the offset to be 0. So we've done our looping through every character, so we can change that offset to be back down to 0. And that's all that's required to display the character. So we then go back up to that piece of code we looked at a second ago. Display character. This is really the workhorse that does the setting on and off of the pixels. So we bring in the RGB value. We bring in the hue, saturation, and value, which we've set internally before. So self.hs to RGB, self.hue, self.saturation, self.brightness, and we convert them to RGB because that's what the Pico Unicorn Pack uses. And then we have two loops where we have the row loop. So we're going to look through all the different rows, and we say the length of the character, because the characters are always the same length, no matter which row you look at. We just take the first one and we just say that's going to be the length for the whole glyph. And then we say for each column in that particular character, we're then going to say X and Y become equal to these values. We then clear a gap and then we write the pixel. So if it's a 1, if the row and column is a 1, then we set the X and Y to be red, green and blue, which is the values we've set above. Otherwise, we set the pixel to be black. And the little check there just makes sure that we're in that window of pixels, so it's less than 16 and greater than -1, 0. I could have just said equals 0, but greater than -1. And then we set the offset, the internal offset, to be whatever the length of the characters are plus the gap. So if it was 5 pixels plus 1, then the position, the offset, is then marked in our memory. And that's it. That's all there is to it. So I want to do one last fun thing. We can add to our fonts and see that this works. So let's create a new symbol. Let's create one that we're going to call Smiley. Smiley. I always type that wrong. Smiley. And we're going to make that to be a list. And then we're just going to define 5 lots of rows. So let's just copy that like so. You can tell I've done this a few times, and then I've actually not designed the smiley, so let me just quickly figure out what that's going to look like. So I think we're going to, yeah, what I will do, I think we'll have 0, 1, 1, 1, 0, then we'll have 1, 0, 0, 0, 1, oops. So it's like a circle. In fact, we can probably copy that row above and do that again, and then do that like the top one. And then we could have maybe, that's the eyes perhaps. Maybe having the outside doesn't work, so maybe we should put the eyes at the top here, and then just have no walls on the smiley's face. So that'll just mean setting those like so. You'll see in a second what this looks like, if you bear with me. And then we want the smile, so let's just have that bottom bit as the smile. So actually those eyes need to be a bit further up there, and that means that one's going to be empty, and the top one's going to be empty as well. Right, that's my smiley. I'm sticking with it. I think maybe the eyes look a bit weird, so let's just have them like that. We can probably afford to have the eyes like squares like that. Right, okay, so that's our smiley. So then we just need to save that, and then we need to upload. I need to stop the code that's running currently. I can just do Control-C, and I just need to upload by right-clicking fonts, upload the code to the Pico. Yeah, want to overwrite whatever is in there currently, and then I want to go to my scroller code, and when we have all those if statements, I need to add a new one, which is the smiley one. So let's go here, just grab the bottom one, and let's say if the character is, let me have a think what we're going to use as the smiley. Let's go for that character, which is like the squiggly bracket, squiggly right bracket. So then we're going to display smiley. Okay, so if I now go back to my demo, I do need to upload that as well. Upload that to the Pico, and we'll go back to our text message there. So let's go back to the Kev one. Let's just uncomment that, change it to Kev, and then let's do that little smiley bracket there. Right, so if I save that and then I run that, let's see what happens. So it's pulsing Kev, and then there's a little smiley face at the end. How cool is that? So yes, Dale is saying with a dictionary you could have something like braces, A in speech marks, and then colon, and then the binary array. And that's precisely what I did in the later version of this. In fact, if you want to go over to, let me bring up my code here. If we go over to here, and I change this to the branch of code which is called, that's not the right piece of code, is it? That's my subscriber account one. I'll show you that in a second. We go over to the unicorn scroller and we change the branch. So instead of looking at the main branch, we look at the binary branch. Wait for that to come on. Click on that. Go to the binary branch. Yep, let's force checkout. It's going to write over that. Tell you what I'm going to do before I do that, because I'm working in the same code area at the moment in Thonny, so it'll erase everything. So let's just save what we've got on here. We want to save all these. Let's go back to Visual Studio. Visual Studio has got the benefit of having Git built in, so those changes I've made there, it will show you the change that it's made, such as in the font we've now got the smiley. So let's add these as our live changes, write that to and publish that. So once it's published that, we can now change the branch to be our binary branch. And I just want to show you what the code looks like in there for, there you go, Dale. So that's exactly what we've done. So I've created a class called Johnny5. I've then created some details such as the name and the height, and then the characters, another dictionary, and then each element in the dictionary, like space, then is defined in binary, and then A is defined in binary. So you can see it's the same array, but it's got this OB at the beginning, which tells Python that that's a binary representation. So I've done that all the way down there, and then I've got some extra things in there, like a piece of code to find the character width, and then a piece of code there to initialize, because what we need to do is pre-calculate the widths of the of the fonts, because if we don't do that, it does it while it's doing the loop, and it has to do it each time for the entirety of the font. So pre-calculating them is so much better. We could eventually just write this out to a proper font format, a binary font file, but the actual code then becomes really complicated. So in the scroller.py, we're working with things like frame buffers. We've got to do things like fill the leading zeros, because when you unpack a binary number, you don't get the leading zeros back. And then you have to draw things like the character from a frame, and you can use things like frame buffers, which is built into MicroPython. So it gets very complicated. I originally was looking at using the frame buffer library on the hat, but the character height is 8 pixels, not 7. So that's why I had to go and use my own, roll my own code. But then I learned quite a bit from doing that. So let's go back and change that back to our main branch, and then we can carry on. So the other thing I wanted to just show you there then was the how to grab the YouTube subscriber count. So I've got this piece of code here which gets subs. Yeah, I think that's safe to show. So I've got things like my MQTT broker. I've got an IP address for that. We give this particular piece of code that's going to run a client ID. We give it a topic, the MQTT topic is going to publish to, and then we've got some code which is when it's publishing, we can add extra things in there, and I've just made it print out to the console what it's doing. And then we do things like connect and publish to that particular topic, and then we create an object using the Google API client discovery function. So it gets a bit complicated, and we want to use the version 3 of the YouTube API, and I have a developer key which is in my secret file there, and then that gets passed through, authenticates that it's me, and it grabs my current subscriber number. So I'm not sure if this has got code in it that will actually run and work. Don't think it has. So if I go to sub count number, nope, don't think that has it as well. Retest, don't think that's it. So yeah, this is like a work in progress at the moment. So I can run it, and I will get the live number of YouTube subscribers that I have. But this essentially will run on a Raspberry Pi as a service, which is another video I'm going to be doing very soon. So that I think is everything I wanted to cover off on the code side. And I've got a couple of other things I wanted to mention. So if you want to help out the show, There's my correct button for doing that. You can help out the show. It's very expensive running this show, as you know. So if you want to help me out, you can go over to buymeacoffee.com/Kevin McAleer. Buy me a coffee. That really helps pay for all the expensive equipment, the software I use to edit, the software I use to do live streaming, which is a subscription-based one, the graphics software I use to do all the graphic stuff, all the royalty-free music, and the website hosting too. So there's a lot going on there. So if you want to help me out, you can do that. I love these these little buttons I've got on here, so I can do things like mind blown, or the money one, which you've just seen. Right, so we can turn that off, and let's go back to the other button with the call to action, which is we do a live stream every single Sunday. I've mentioned that earlier. They're all the different time zones, just in case it's easy for you to sort of look that up and understand where you are in the world and how that affects the Greenwich Mean Time, which is usually when I'm broadcasting. I think we're at GMT +1 currently, but that does change. And then website-wise, so if you've not checked out smarsfan.com, there's loads of really good information on there about building robots, Smars robots and other robots. There's a Python learning platform on there, so you can have a quick learn of Python on there for free. All kinds of good stuff. Now there is a new website I wanted to show you, and that's where I'm currently hosting a lot of the project work that I'm doing. So let me just bring that up. And that's got some things on it like the Pi stands. So if I go over to here, so if you go to Kev's Robot, and it's HTTP, not HTTPS. I've not got the certificate working yet, so it does say it's not secure, but it's running on the little Raspberry Pi cluster just behind me, just there. So you can see there, Pi stat, and I need to optimize some of those images as well, because it's taking a little bit longer to load than they should. But yeah, the Pi stands, we've got the Pico stand, we've got the Zero stand, and we've got the full Raspberry Pi 2B, 3B or 4B sizes. And you can see on there, you can grab the STL files for all of them for free. And if you want to help me, because I do give these things away for free and I put a lot of effort into it, lots of iterations of reprinting these things and reprinting them until I get them right. So you get all the benefits of that completely for free. And yeah, printing wise, I think I originally said print it face down, but actually when I tested it, printing it standing up is a little bit better. I might change that advice. And then we've got a video there about the air quality sensor from last week. You can see that being used there, and you can see all the three displays side by side there as well. You can see Isaaca's neck just hiding there as well. And there's another shot. And there's the grow hat. I think I've still got my faulty sensor on there. If you're watching, John, need to get that swapped out. And there's the Fusion file for putting that together. So I can go through the Fusion if anybody was interested in how to put one of these stands together, but they're really, really quite simple. The other thing I wanted to show you as well was previously I'd showed people BurgerBot. This is work in progress at the moment. I'm not very happy at the moment the way that these pieces connect in. I'm going to replace these lugs that are on here with screws, because they don't sit flush. You can see there's a bit of a gap, and that's just to do with the way that these things sort of spread out a little bit when they reach the plastic. And if you try and file too much away, they become really loose, and that kind of defeats the object of that. There is another piece which sits on top, which I've just removed, which has some studs on there which are compatible with all those generic building block toys that you know well. So yes, the thing I couldn't previously show because it hadn't been launched yet was the Pico shim, so the motor shim. So this, if I can get that to display there, this is a new thing from Pimoroni, and it makes connecting to a Raspberry Pi Pico or Pico LiPo like I have here really straightforward. You just push it on the back like the pack we've just been looking at, and then they connect through to the motors. So they sell these motors with the little shims on them, so that you can plug in just with a couple of wires, and you don't have to do any soldering, and they just work really, really well. They do two different types of the motors. So I've got one of the this one is kind of like side loaded. If I just put this next to it and show you what I mean, if I just hold that there, you can probably see. So this has the header on the side, whereas these ones have the header sort of facing up. So there's two different types you can get there, but it makes it so much easier than soldering it. I've done quite a few videos where I'm soldering these things and they're just a pain. So the fact you can just sort of quickly plug them in and away you go. So I will be releasing the STL files for the BurgerBot once I've gone through a few iterations of just getting that just right, but it's not far off, to be honest. And I will do a video on this working as well with the rangefinder, because it's a very nice and easy robot to build. It only has two motors, 2 wheels, and these little sort of stump things, studs, technical term, to keep this thing upright and working. So yeah, really pleased with how that works and how simple that makes things. And the actual motor shim just comes as like a little pack like that, so it's very simple, and you just simply push that onto the back. So Pico motor shim, that's what it's called. I think it's just, yeah, Pico motor shim on Pimoroni.com. Very simple. I just wanted to show you that because I love those kinds of things, anything robot wise. Yeah, so I think that's everything. The other thing I wanted to let you know about was, so for the next 2 weeks there'll be no live show. I need a well-earned break. So I shall see you back on the 12th of June for the next live stream, but I will try and get a midweek video out, probably on how to run Python code as a service on a Raspberry Pi, because that's something I had to do for all the Grow hats and for the Enviro hat and so on, so it can continually broadcast its data to an MQTT server. Even if there's a reboot or something goes offline, it can restart itself and self-heal. So it's very easy to do that, and it's not something I knew before, so I'm going to share that with you. Cool. So this is the point in the video where we are going to do something I forgot to do, which was I asked Alex to send me a list of all the people, and we can display that on the thing. So let me just grab that list of names there. So let me grab that and stick it in our Thonny code, and I'll show you this in a second. There we go. Make sure we're on the right code base there as well. I'm aware that you can't see the screen at the moment. Right, so what I'm going to do, I'm just going to put a big block of text in there, and then I'm just going to grab the other block of names, and let's paste that in as well. And then we can have that on the stream. That's the intention there. Right, so if we go back over to here, I just need to create a little message and stick all your names in there. So that's probably one. Let's do these as well. We can probably cut and paste that to make this a bit quicker. I just copy that, then I only need to put the little comma at the end. Let's do that. Oops. There's a few names I don't recognize in here, so welcome to the stream. So there's Richard, we have Ryan, we have Bit or Twisted, we have Martin, we have Veden, Fleece, and Kramer's. Right, okay, so what I'm going to do is just do one at a time. So let's just comment them ones out and comment out me, and then let's make sure we have that in shot. Yeah, we have. So if I now run that, what have I done wrong? What have I done wrong? Type something. There we go. So let's just do message equals, and then that. And I'll just comment you out for a second, and then let's just give a bit of space so I can see where they are. Right, let's try running that again. Okay, so that's a little bit slow there. I think we'll speed that up. So there we've got Hybrid Robotics. Hey Dale. Let's now change that to Plasma. Let's have Plasma's name scrolling past, and this will be a little bit quicker, I think. There we go. Look at that, Plasma whizzing past there. Let's do Richard. So Richard's next. There we go. And we can do Ryan next. Ryan, is it? Ryan. There we go. Awesome. Let's do Bit and Twisted. Bit and or Twisted. That's a cool username. Let's do Veden next. Oops, I pressed run then and didn't wait. Veden, Fleece. And Martin. Another long-term subscriber. There we go. That's in Parker. And then we've got Kramer's. Let's do that. And finally,
there's one more as well.
Yeah, Mrs. Brent. What have you pasted one more in, have you?
Zach S.
Oh, let me just grab it, Zach S. Oops. there's all my personal details for you. Great. That's what I want on the stream. There we go. And then let's go back to Thonny, and then let's paste that in. And then equals, oops, just killed your first character there. This is a good test that the code works. We've tried all different combination of characters, letters, uppercase, lowercase, all work perfectly. Awesome, great stuff. I just wanted to make sure we got that on the stream before we break. Okay, so this is the point in the video where if you're watching this on replay, I'll say thank you very much for watching, and I shall see you next time.